Unit 10, Lesson 6. I can solve for angles in inscribed quadrilaterals. This is a short lesson. Let's go ahead and define what we mean by inscribed quadrilaterals. Quadrilaterals are definitely four-sided polygons, but inscribed in this case means a quadrilateral that's drawn inside a circle. But more specifically, the quadrilateral is not just inside the circle. Look where its vertices are. They're on the circle. So the difference would be it's not just a quadrilateral that would be in a circle. You have to pull each vertex so it's sitting on the circle. So it's a quadrilateral drawn inside the circle with all vertices on the circle. Okay, that's what we have. So let's go play around with this and see if we can come up with a relationship. I really like this problem because it's a little bit of a puzzle, and it really goes at to what I think geometry is all about. You need to find relationships and use relationships you already know to find the new ones. So quadrilateral NBLK is inscribed in circle P, and the measure of angle L is 80 degrees. Let's go ahead and annotate. Check. Find the measure of angle N. So I'm looking for that over there. We might say that there's absolutely no way we can find that. We only have one little piece of given information. There's no way I can find angle N. But it turns out there is. We got to zoom out a little bit and think of some other relationships we know. For example, how many degrees in the whole circle? Well, a circle is equal to 360 degrees. Okay. So what else do we know after that? Well, if I look at angle L happens to be with the vertex on the circle, so this is inscribed. So if that's inscribed and this is 80, let's go ahead and turn the light on here for angle L. And if we do, it's going to highlight the intercepted arc, KB. Why is that helpful? Well, what's the relationship? This angle is half of this arc. So what would this have to be if 80 is half of it? It means you have to double this, and you get 160 degrees for arc KB. And that's pretty cool. Where do you go next after that? Well, we use inscribed angles to get this arc measure. Is there any way I could figure out what this other side of the circle is? And the answer is absolutely. You know that this entire other green arc, together the green and the pink make 360. So pink plus green is equal to 360. So you know the pink plus the green equals 360. Well, the pink happens to be 160. I don't know what the green is, but it has to make 360. So let's go ahead and just take 160 from both sides. So the green is equal to 200 degrees. Oh, that's great. This whole thing here is 200 degrees. This is 160, that's 200. Okay, well now what? I still need to know what angle N is. And that's the cool part. Look at inscribed angle N. It opens up on the green arc. So the green arc is the intercepted arc for angle N. And you know that this inscribed angle with the vertex on the circle is half of its intercepted arc, so this is now 100 degrees, and we found our answer. The measure of angle N is equal to 100 degrees, and we did that in 3 steps. We were able to take this and say, hey, if this is 80, then if I double it, I've got this. Wait a minute, if I know this, I can find the other arc in the circle because they have to make 360 together. Hey, wait a minute, if I have this arc, I can jump back in to that inscribed angle, which is going to be half of this. So that was kind of a fun puzzle. Is there an overarching relationship? Well, take a look at these two angles. They're opposite angles. 80 is opposite the 100. Is there a relationship between 80 and 100? Absolutely, they're supplementary. And that turns out to be the relationship here when you have an inscribed quadrilateral. The opposite angles turn out to be supplementary. So K and B also sum to 180, just like L and N. And again, this happens for a quadrilateral that's inscribed, meaning vertices on the circle. So if I come over here to try and sum that up, I could say, for example, like this is A and this is B, this could be C and this could be angle D, and I could say, for example, that A plus B is equal to 180. Okay, those are opposites. And C plus D, they're also supplementary for inscribed quadrilaterals. A more precise way to say it is that the opposite angles in an inscribed quadrilateral are supplementary. Okay, that's pretty cool. So let's go see a different application. If we come over here, I can't do what I did on this one. When I had the number 80, I was able to then make this 160, no problem. But here, they didn't give me a nice, easy number to start with. They gave me an algebraic expression. So I'm kind of in trouble, and I need to know that relationship. Hey, this is a quadrilateral, and it's inscribed in the circle. So then I know these opposite angles are supplementary. That is the key. Now I'm looking for angle K, so I'm not done until I have the measure of that entire angle. I need to be careful about that. In fact, to avoid messing up and maybe stopping with just X, I'm going to come down here at the bottom and put something like the measure of angle K is equal to, let me zoom out so we can see, and put a blank. I really don't want to mess that up and stop with just X. So I know they're supplementary, so I know the measure of angle K plus the measure of angle B equals 180. I can go ahead and substitute 6x plus 13, and then 4x plus 7 equals 180, and it's nothing more than algebra at that point. Got my like terms, so I'm going to have 10x's plus 20 is equal to 180. Let's go ahead and take 20 from both sides. 10x is equal to 160. Divide both sides by 10. Then our x is going to be 16. I'm not done. I need to go back and substitute it in and figure out that the measure of angle K is equal to 6, in this case, times 16 plus 13. I just took this expression for K, and I'm substituting in the 16 for X. That's going to be 60 and 36 is 96 plus 13. I think that's going to be 109 degrees. And then I'm done, and I feel good about it. I found the right thing. In summary, inscribed quadrilaterals, the opposite angles are supplementary. Good luck.